Indiana University East School of Natural Sciences and Mathematics, naming binary molecular compounds. Binary molecular compounds contain atoms of two different atoms, a virtue of being binary, and the molecular compounds. So they contain, as we discussed, either semimetals plus nonmetal or nonmetals only. And the key thing is we need to make sure that every time we name a compound, we order the name, we order what we write in the same order. And to do this, when we write the name or in the formulae, we put the most cation-like element first. What that means is the most metallic. The one with the most metallic character, which is closest to the bottom left corner of the periodic table, and the second compound to be listed is the more anion-like, which is the least metallic, closest to fluorine at the top right hand corner. Now how we do this in terms of naming is that for the first element we keep the name, as we did basically for binary ionic compounds. In the second element, just like ionic compounds, we keep the root of the element only, and then we add an IDE. So for example, hydrogen sulfide. Now hydrogen containing compounds have separate rules that will be discussed separately, but we can use this as an example. We will write hydrogen because that's the first one, and sulfur would become sulfide, and silicon, SiC, will be silicon because that's the one closest to the bottom left. Carbide, carb IDE. Problem we've run into here is that so far we've only figured out how to uniquely identify the pair of elements. So here, if I have nitrogen and oxygen, based on the rules above, we'd have nitrogen oxide. But which of these is nitrogen oxide? So this is getting confusing, and so we need to use Greek prefixes to denote the number of atoms of each element. And so we put a Greek prefix in front of each of them, each of the elements, at all times, except with the proviso that if there's only one atom of the first element, we skip the prefix mono. So for example, here, phosphorus pentachloride, so that's one phosphorus, P, and then penta means 5, so that's 5 Cls. Dinitrogen, so that's N2, pentoxide is O5. Nitrogen tetroxide is NO4. For these compounds, to write down the names, we have to just follow the rules again. C, here we have C, carbon, and then we have two oxygens, so that's di, and then oxide. And for N2O, we have two nitrogens, so it's dinitrogen. It's dinitrogen, and then here we have one oxygen. If it's the second element, you still need to make sure you have the prefix. So it's monoxide.